The midbrain does not think. It does not make choices or understand consequences. It handles the next 15 seconds. It gets us from moment to moment alive. The midbrain tells us to eat. It tells us to defend ourselves, even kill. It fires our sex drive. These are all behaviors that are critical for survival. This is similar to what the scriptures teach us as the natural man, or where we have our carnal drives. Ordinarily, the frontal cortex keeps the midbrain in check. It exerts a top-down control over the midbrain. But in addiction, this top-down control fails, and the midbrain becomes more powerful at guiding behavior than the cortex. In other words, in addiction, something goes wrong at a level of brain processing long before morals or personality or choice. Now, how do we know all of this? That drugs work primarily in the unconscious survival midbrain and not in the rational decision-making cortex. We know this because of a very famous set of experiments done in the 1950s on mice. The midbrain's role in reward was discovered by Dr. James Olds and Dr. Peter Milner. They found that a mouse will press a lever to deliver a tiny electric current to two very small, very specific areas of the brain, the ventral tegmental area and the nucleus accumbens. And not only will a mouse press a lever to deliver an electric current to these two areas of the brain, that's all he will do. He won't eat, he won't mate with other mice. If you put an electrified grate in front of the lever and shock the mouse, he won't step off the grate. He just continues to press the lever, ignoring all other survival drives until he dies. Olds and Milner had discovered the pleasure centers in the brain. Our brains have these same two areas, and the nerve pathway that runs between the ventral tegmental area and the nucleus accumbens is known as the pleasure circuit. Later, scientists discovered that a mouse will press a lever to deliver drugs to these same two areas, and again, that's all he will do. He won't eat, he won't mate, he just sits on that electrified grate and fries and keeps on pressing the lever until he is dead. So mice can get addicted to drugs. Big deal. Well, think about it. Drugs produce a very powerful, rapidly fatal addiction in a mouse. A mouse has no personality. A mouse does not weigh the moral consequences of pressing the lever. There are no mouse gangs selling drugs to other mice. And yet, mice can still become addicted. This research dramatically weakens the idea that the cause of addiction is a personality disorder, or bad morals, or a bad social or family environment. These things might accompany addiction, but they cannot be the cause of addiction. It shows that in addiction, the drug hijacks the survival mechanism of the midbrain. Now the drug is in the number one survival spot. The solution to starvation is no longer eating, it's the drug. And the relief from being burned by an electrified grate is no longer in simply stepping off that grate. The relief is in the drug. The drug and survival are now so close together that as far as this addicted midbrain is concerned, they're the same thing. In other words, the drug and actual survival are indistinguishable. This is what happens when someone is in the throes of their addictive cycle and craving a substance or to engage in a behavior. The midbrain overpowers the frontal cortex and takes control.